Section 4.4, permutations when objects are identical. So consider the words bike and book. How does the number of ways that the 4 letters in each word can be arranged differ, and why? So we know that this one would be 4 factorial because you have 4 choices for the first spot, 3 for the next, 2 and 1. But this book word is a little different because those O's are not distinguishable. They are identical. So here someone has gone and made all the arrangements. So like I said, this was 4 factorial or 24. But book, there's only 12. And there are half as many because even though they both have 4 letters, 2 of the letters in books are the same. So for example, OOKB is the same as OOKB. We can't tell which O they're using. That means you have to divide by 2 to get rid of all the extra. Okay, so for each way that you use the O's, there's 2 ways you can do that are undistinguishable. Okay, that they are the same, are identical or undistinguishable. Let's go through example. Here's Tom. Tom's being very good in putting away the dishes after supper. In addition to putting away the bowls, cups, and cutlery, he has to stack 7 dinner plates. 3 of the plates are white and identical, while the remaining 4 plates are red, blue, green, and yellow. Okay, so how many different ways? If all 7 plates are different, how many ways could he stack them? Well, he'd have 7 choices for the first position and 6 and 5 and 4. We already know that that would be 7 factorial. He decided to think about the plates as if they are different. To do this, he represents the 3 identical plates using 3 different codes, W1, W2, W3. He then used R, G, and Y, and B. List all the ways the plates could be stacked. The 3 white plates are stacked on top of the 4 colored plates, and the 4 colored green plates are stacked in the order red, green, yellow, and blue. Okay, so I'll show you if they did that here. Oops. So we could have all of these different ways, white, all the ways to do the white. But really, those all look the same. And how many cases are there? There's 1, 2, 3, 4, 5, 6. There's 6 different ways. Interesting. Recognizing the whites plate are in fact identical, how many arrangements are really the same? How does this number relate to the number of white plates? So all 6 of them are same since the 3 white plates are indistinguishable. There are 6 ways that the 3 white plates can be arranged. White, 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 but they're different white plates, okay? So this can be calculated using 3 factorial. Use your answers for part A and C to write the expression that represents the number of different ways that 7 plates can be stacked. So what we're going to do is we're going to go 7 factorial divided by 3 factorial, which is 840. So there's 840 ways to stack these plates. So what we did is, since there's 3 that are repeated, we took 7 factorial and we divided it by 3 factorial. Because each way to arrange it has 6 exactly the same ways because they're undistinguishable. Suppose that he had to stack these plates. Write an expression to represent the different ways. So there's 1, 2, 3, 4, 5, 6, 7, but there's 4 that are the same. So we would divide that by 4 factorial. So what we would be left with is 7 times 6 times 5, because everything from 4 on would cancel out. That's 30 times 7, which is probably 210, I bet. Oh, we just need to write the expression. Okay. Suppose he had to do this. So there's still 1, 2, 3, 4, 5, 6, 7. So it would be 7 factorial. Let's look at, we have 2 repeated there, and then we have 3 repeated there. Okay. The next time that Tom puts away the dishes, he stacks a plate and it's represented by 10 factorial, 2, 3, 4. How many plates would be stacked? So there's going to be 10 plates. I can tell that from here. And it looks like he has 2, let's say blue. We could choose any color. 2 of them are blue, 3 are red, and 4 are yellow. Okay, I can tell that there are those many repeated. Okay, and then the final expression to represent the number of permutations of n objects where A are identical, B are identical, and C are identical, it's n factorial over A factorial, B factorial, C factorial. That's our main idea here. In the mountainous regions of India, China, Nepal, and Bhutan, it is common to see prayer flags. Each flag has a prayer written on it, and its color is used to symbolize different elements. Green is water, yellow is earth, white is the air and wind, blue is sky or space, and red is fire. How many different arrangements can the same prayer can be made using these 9 flags? One's green, one yellow, 2 are white, 3 are blue, and 2 are red. So what we would do is we would go 9 factorial divided by 2 factorial, 3 factorial, 2 factorial. And what I would do is I would actually write this out. And I would see what gets canceled. So this is 2, 1, 3, 2, 1, 2, 1. So I can see right away that that would cancel out. My 3's would cancel out. Here I have a 2 and a 2. That would get rid of the 4. So I would have just 9 times 8 times 7 times 6 times 5. Okay, and I think that down here they will have this figured out. 9 times 8 times 7 times 6 times 5, so they put that in their calculator. Okay, next question. How many ways can the letters of the word Canada be arranged if the first letter N must be N and the last letter must be C? Okay, so there's a couple of undistinguishables. There's a couple of A's there, but we said we must fix the first letter and the last letter. So we've already put N here and C there. So we're really only looking at 1, 2, 3, 4 letters, how we can arrange those 4 letters, but of those 4 letters, 3 of them are repeated. So this is going to simplify since it's 4 times 3 times 2 times 1 over 3 times 2 times 1. It's really going to simplify to 4. So I think the answer is going to be 4. And let's look what they did here. So they said they've done that. It's really only 4 ways, and they've actually drawn out those 4 ways. So whenever you have to fix something, it's a good idea to actually draw out the diagram and show how you're fixing them. Okay, just to finish up our key ideas, there are fewer permutations when some objects are identical. So there's less. This is because some of them are identical. The number of permutations, this is our formula, where A are identical, B and C is n factorial over A, B, C factorial when we have n objects. Okay, and they give us an example. Need to know, dividing it by A, B, C factorial, and so on deals with the effect of repetition caused by objects in a set that are identical. It eliminates arrangements that are the same and would otherwise be counted multiple times.